Hello everyone, this is Vanditha from Sri Venkateswara College of Engineering. Today I am here to discuss a few words about the topic registers regarding microcontrollers. So let's start with today's topic. First, let's see what are registers, its types, and what are the major advantages, disadvantages, why do we use registers, and other things. First, coming to what is registers. Registers are a type of computer memory used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as processor registers. So the CPU which uses registers, they are called as processor registers. So let's see what is a processor register. A processor register may hold an instruction, a storage address, or any data. A data can be a sequence or an individual character. So the sequence of data can consist as many as characters as it can hold. The computer needs processor registers for manipulating data and a register for holding a memory address. So the computer will mainly require two types of registers, one to hold data and other to hold a memory address. The registers holding the memory address located at the calculate the address of the next instruction after the execution of the current instruction is completed. Here let's see a few registers, its symbols, number of bits and their functions. First, coming to data register, it is represented as DR. It has 16 bits functionality. It holds memory operand. So there are next comes the address register. Its symbol is AR. It has 12 bits, holds address for the memory. Coming to the accumulator, its symbol is AC. It has 16 bits. Its function is for processor register. Coming for the instruction register, it is mainly represented as IR. This is most common register we have used in computer science. Its number of bits is 16. Its function holds instruction code. Next, coming to the program counter. Program counter is mainly used symbol is PC. It has 12 number of bits, holds address of the instruction. Next, coming to temporary register, it is called as TR. 16 bits, holds temporary data. Input register, it is represented as symbol INPR. It has 8 number of bits, carries input character. Output register, it's represented as symbol OUTR. It has 8 number of bits, carries output character. You can pause the video for a minute and just look into the registers, their symbols, number of bits and functions. Next, let's see different classes of CPU registers. First comes the accumulator. This is the most frequently used register. It is used mainly to store data taken from the memory. So when we use this accumulator is like a temporary variable. We just like in order to move a variable R1 into R2, and there is like some other function going on, so we can store the value of R1 in the accumulator for some time, and then from the accumulator it can be transferred into R2. So this is how accumulator works. Next, coming to memory address register. Memory address register is mainly derived as MAR. It is often derived as MAR. It holds the address of the location to be accessed from memory. MAR and MDR together facilitate the communication of the CPU and the main memory. Next, coming to MDR, that is mainly represented as memory data register. It contains the data to be written into or to be read out of the address location. Next, let's see the general purpose register. These are numbered as R0, R1, R2 until Rn-1. They store temporary data using only ongoing operation. It contains the access by assembly programming. Modern CPU architecture tends to use GPR so that register to register addressing can be used more. Next we'll come to PC, which is mainly called as the program counter. Program counter is used to keep in track the execution of the program. It contains the memory address of the next instruction to be fetched. PC points to the address of the next instruction to be fetched from the main memory when the previous instruction has been successfully completed. Program counter also functions to count the number of instructions. The decrementation of PC depends on the type of architecture being used. If we use 32-bit architecture, the PC gets incremented by 4 every time the next fetch instruction is be done. Next, coming to instruction register. Instruction register is mainly called as IR. holds the instruction which is just about to be executed. The instruction from the PC is fetched and stored in the IR. As soon as the instruction is placed in the IR, the CPU starts executing the instruction and the PC points to the next instruction to be executed. That is, when instruction register gets a execution like an instruction to be executed, it immediately stored in IR. The instruction that has to be executed, it's stored in IR. After it is stored in IR, the instruction is placed and the CPU starts executing the instruction, and then the PC points to the next instruction to be executed. Next, coming to CCR, that is condition code register. Condition code registers contain different flags that indicate the status of any operation. For instance, let's suppose an operation caused the creation of a negative result or 0. Then these flags are high, set high according to the flags are. Then we have 5 condition code registers. First is carry, which is represented as C. Next is overflow, which is represented as V. Next is 0, represented as Z. Negative, represented as N. Extend, that is represented as X. Let's see each one of them. First comes the carry. It is set to 1 if an add operation produces a carry or a subtraction operation produces a borrow. Otherwise, it is clear to 0. Next, coming to overflow, that is V. Useful only during operations on unsigned integers. Coming to 0, that is Z, it is set to 1 if the result is 0, otherwise it is clear to 0. Next comes the negative N, meaningful only in signed number operation, set to 1 if a negative result is produced. Next we will come to extend, that is represented as X, functions as a carry for multiple precisions arithmetic operations. So we have seen what is instruction register and condition code register. Next, let's see the diagram. So this is the main memory. The CPU can access the main memory directly. The MDR, that is memory data register, is directly connected to the main memory. MAR represents the memory address register which contains of the next instruction, address of the next instruction to be executed. PC is the program counter. IR is the instruction register. ALU is the arithmetic and logic unit. It performs many arithmetic and logical operations which is needed for the computer. So this is the diagram for the register. Let's see the hardware register. In digital electronics, especially computing, hardware registers are circuits typically composed of flip-flops. There are many number of flip-flops, and the hardware registers are used in the interface between software and the peripherals. Software writes them to send information to the device and reads them to get information from the device. Some hardware devices also include registers that are not visible to the software to their internal use. Depending on their complexity, modern hardware devices may also have many registers. So we have seen what is software registers, hardware registers. We have come to the end of the video. Hopes you have liked the entire topic what I have discussed. Thank you for watching.